All right. We are here today with a live coding session. This is the MetaMask DevRel team, and we're going to be going through a kind of a live coding session, kind of workshop that we've built here on the DevRel team, which is a kind of NFT, I guess, NFT gated ballot voting system that could be applied to any type of a Web3 Dapp. I mean, it's great for, I think, a voting system, but I think a lot of the techniques and a lot of the things that we do inside of these contracts and inside of these full stack web application are really good for anyone who's getting involved into Web3 or just wants to see a real world project where everything is put together from the front end to the back end to the smart contracts and everything. So we'll get started. We have a team of people here today. Myself, I'm Eric Bichard at HTTP Junkie on Twitter. And we'll just go down the list. We'll start with Chintaka. Give us a little brief intro, who you are, what you do here on the team, what products you might work with, etc.
Yeah. So my name is Chintaka. I'm based in Sri Lanka. So mainly work with DevRel team and basically Consensys with mostly MetaMask product and linear product, and basically building out full stack application that use in Web3 space, building nice use cases and demoing it basically and creating content around these things. So yeah, that's pretty much it.
Yeah, and Chintaka, I think pretty much in the project that we're going to show, you spiked a lot of, you did a lot of the work on the smart contract side of things.
Yeah.
So as we have questions about the smart contracts, we'll probably go to you with those questions, although you and Alejandro both worked pretty side by side on them. But yeah, next we'll go to Alejandro, who's going to be doing most of the live coding in the session today and the walkthrough. So Alejandro, go ahead and introduce yourself, tell everybody what you do, and
Okay.
yeah.
Hello, this is Alejandro, and I'm based in Peru. I'm a software engineer. I do a lot of full stack development. So yeah, pretty much pretty similar to Chin. We are part of the same team, and yeah, we create sample dApps to showcase like different consensus products like MetaMask, like Linea or Infura, and so on. So yeah, I also have knowledge on UX and some UI design. So I often focus on improving these areas of the dApps I create. So yeah, at underscore CXLM on Twitter, and yeah, pretty much that.
Absolutely. Yeah, I think I kind of think sometimes it's like, Chintaka's doing a lot of the back end work and you're doing a lot of the front end work, but I think we all kind of jump in different areas and we all work kind of full stack. So it's really great to have a team that can do that. Finally, we'll go over to Francesco. Francesco, I don't think a lot of people need an introduction to you. Most people know Francesco. I heard at the last conference that Francesco is famous. So probably no introduction needed, but go ahead.
You guys are the one. But yeah, thanks, Eric. Yeah, I'm super excited to this session. We've been running for quite a while those MetaMask developer committee call, and we actually ask ourselves, so what people mostly like developer were asking in the past, and everybody want to see more like live code session. And then we thought about why we're actually jumping in some more like informal live coding session with the DevRel team, building something cool, So for everybody out there, they just want to learn, and this is fine-tuned for everyone, right? And I think we'll try to ask question every time, give a context to anything, and I think it's also a great opportunity to learn something and really give us feedback on what you see as live coding next. And that's super exciting to be here, and excited because this work is a really like strong working team, and this is just some basic fruit, but there is
and it's just the beginning too. Like we're gonna do a lot of these live streaming. And so today is kind of a mix between live coding and showing you something that we've already built before, right? We had to kick off these kind of live streams with something that was ready to go. So although we're not going to be completely building this thing from scratch, we are going to show you how we started building it and go kind of step by step into kind of how we got to the finish line of it. And then, of course, for future live streams, we're going to have a lot of other ideas that could be similar or could be just us getting on and building something brand new from the scratch. So it could be anything. So try to join into all the live streams. And with that being said, I'm going to shut up and I'm going to turn on Alejandro's shared screen here. And we're going to start walking with him through basically the beginning of this project, which started with using our CLI. So I'll go ahead and turn this on, and I'm going to pull my mic down for just a minute so that Alejandro can walk you through. Alejandro, can you make that terminal screen just a little bit larger, like a Command plus on that guy? Let's just do a Command plus. There we go. You could have left it where it is, but awesome. So I'm going to let him take it over, and we're going to start with the CLI, right?
Cool. Yeah. Actually, okay, I can start. Basically, the way we started the project, and basically the way we start most of our projects right now is by using our CLI, which is a CLI tool that we created to scaffold projects that comes with the MetaMask SDK install and a blockchain package that allows us to add the smart contracts and deploy smart contracts directly to Linea. You can add configuration to deploy to other networks, but yeah, let's give it a look. That will be easier. So by now we can call npx at Consensys create Web3 template, and we can add a name for the project. Let's try this first. Let's say live stream project. We can choose between React or Next.js. In this case, we're going to use Vite because it's going to be simpler. We can pick between Foundry, Hardhat, or none. If you pick none, you're going to have like a simple simple project with without a blockchain package. If you choose one of these, you're going to have a turbo repo or a mono repo that will contain two different packages. In this case, we're going to use BNPM because it's faster for us. And here it is.
I just added the repo in the chat for anybody that want to just follow Alejandro here.
Awesome. Yeah, great. So
which
now we
repo did
can
you put in there?
The CLI
Okay,
create Web3 template. Yeah.
Awesome.
Great. Right here we have our live stream project. So let's give it a look to what we have right here. First, let me zoom in a bit. Probably like this, it's going to be cool. First, let's run a VM install. So we can have all the dependencies installed right here. But basically what we have is a Vite project on the site directory where we're going to have a basic Vite application. But this one right here will contain this connect wallet button that is actually connecting to MetaMask. Let's give it a look after.
So that connect wallet button that's a component, right? That has all of the MetaMask SDK stuff kind of, or it has all the MetaMask SDK JSX stuff inside of it, but there's also like a WAGMI config file as well, right?
Exactly. Yeah. So basically what we did right here was create a component that it's also published on NPM. You can just install the connect wallet button. So we create that component, and now you can, this one, Consensys connect button. This way you can just install the button in your existing project. So you'll be able to.
I have one question. So
yeah.
if they're using WAGMI already, do they have to install like a MetaMask SDK package in order to use the SDK, or is it something that comes with WAGMI?
The button, you mean?
The button you would have to, so the button you would have to maybe install, but like, let's say that you just had WAGMI. Is there a way to use the MetaMask SDK with kind of like, if you want to create like your own button?
Yeah. No, basically, if you already have WAGMI, you're already using the MetaMask SDK, so you don't
just
have to
to make sure you put it in the configuration.
I mean, to connect to MetaMask, exactly.
Yeah, cool.
If you come right here, let me just give it a look. WAGMI config right here, you need to connect to, here we have
like any other
the linear
wallet.
testnet. Exactly. And add MetaMask to connector. So that way you're going to be using the SDK right here with the
So the only
MetaMask.
thing we've told the configuration so far is, hey, we want to use the linear testnet, but we could have chosen any testnet or mainnet. And then we've also told it that we want to use the MetaMask. And then you went and created an actual component which has that button, which, by the way, you also have on a repo somewhere, but that they can install. But that's what's within that connect button component.
Exactly. Basically, the CLI comes with MetaMask and linear testnet already configured, but WAGMI supports several others, or any other network or wallets that you can think. You can come right here, and if you're using TypeScript, you'll have the autocomplete right here, so you can see that we have Wallet Connect or a Coinbase wallet and so on. So yeah, basically you can add whatever wallet you want right here. So this is our project. We have already installed the dependencies right here. I changed the directory to the site directory so I can run pnpm dev. So we see here what we have, which is a template. The first the main thing that we see when we first install the CLI, when we run the CLI. So we have a connect wallet button right here that will allow us to connect our wallet. We confirm right here, and here we can see our wallet connected and the linear block number. For this, we're using VM, so we can check also the blockchain. So let me just do a quick review right here. So here, the block number, we get it by calling this function right here, which is coming from the VM configuration in the client. So here we have the chain, the linear chain configured. So that's why we're connected to linear in this case. And basically, this is the first steps. If we check the blockchain directory, we're going to see that we have a base Foundry project created. There is nothing more here. We are going to be adding our contracts to this directory, and we're going to be compiling them and all that using Foundry in our case. So yeah, basically this is the beginning. I don't know if you have any questions about the CLI or the project or something else.
No, I mean, the one thing that I just noticed that when you first started using the CLI, you had the opportunity to choose between regular React and Next.js, and then you also had the options of using Hard Hat or Foundry, which is great. I guess the one question would be, if someone doesn't have all the Foundry stuff installed, then they might not want to choose Foundry, because so if you want to choose Foundry, make sure you have Foundry kind of installed. There's a little bit more to Foundry than Hard Hat as far as kind of installing stuff on your computer. But yeah, I think Francesco had a question.
No, in general, like for everybody that is kind of starting building their own dApps, it's always about how I'm verifying and auditing my smart contract, or I'm kind of like how I'm starting everything, right? You mentioned obviously with the CLI we're going with Foundry, Alejandro, but maybe like let's give a context. People can either use Hard Hat or Foundry. It's quite straightforward, but you need this step, in order to kind of deploy easily your Dapp on testnet, for example, right? Or even like on on a specific like test use case, right? Anything that we want to add for the people hearing that things around, you know, Foundry or Hardhat during kind of this phase?
Yeah. Well, you see here in the CLI we have two of these options, like Hardhat and Foundry. Yeah, as Eric mentioned, Foundry needs Forge to be installed, so it's a separate installation. Hardhat would be like the easiest.
Yes.
We're using Foundry here because this is a project that we already built using Foundry just to test, but
Yeah.
Hardhat would be the
But
easiest.
let's be
And
honest, Alejandro. One of the reasons why we're using Foundry today is because we're doing a live stream, and Cast
Yeah.
has some pretty cool things that we can save all of our wallet information, and so that we don't expose our wallet and we don't expose our API keys. So of course, there's different ways to do that with any technology. So they're building with Hardhat. It's not to say that you can't do these things with other tools or with environment variables or something, but Foundry just makes it easy with Cast.
Yeah, that's one of the benefits that Foundry has. Like we can encrypt our private keys and just call them by So
question.
it'll be
Sorry, like, before like you moving to the next is do need people to have some pre-dependency installed from the CLI, or like is already kind of everything taken care?
If you're using Hardhat, you don't need to have anything pre-installed in your machine. If you're using Foundry, you'll need to have Forge. But
makes sense.
Besides that, you need just to run the CLI, pick Hardhat, and then run pnpm install or npm install or yarn add, whatever. And yeah, you wouldn't need any other dependency to make it work. So yeah, let's go to the next step, which is this one right here, where we have already our contracts created. We have used Solidity, of course, and Open Zeppelin contracts. For some reason, this says that it cannot find like the Open Zeppelin
packages. Did we run the install script yet?
Yeah. But we have it right here. And we have actually, I have actually compiled the contracts and it works. So probably it's editor stuff. Let me just reload just to make sure. Okay.
Let us know in the chat if you have either any questions or if we need to zoom more on this.
So yes, basically, let's start by reviewing the contracts. These ones are the contracts that we need to use for our voting system. I wrote the base. Shintaka improved them. So yeah, if Chin want to talk about them a bit.
Yeah. So can you open the other contract as well, Alejandro?
This one, the ballot contract.
Yeah, both. So let's get the big picture. So we are building a token gated ballot type, right? So which means anyone come to the app can create a ballot, and anyone come to the website like vote on any ballot, but as long as they have a token like NFT with the attached to their address. So that is the like major idea. So this ballot contract is basically handling all the creation of ballots, handling voting, handling like basically collecting the votes, and basically releasing the results. So that's the whole idea of this contract. And the other contract that you see, the ballot NFT, which is just ERC 721 contract that managing the NFT itself. So we have used ERC this thing, and instead of storing the NFT in IAPFS or any other storage services, we are building the NFT on chain, which means the SVG of the NFT is inside the contract itself, and it is dynamically generated based on the token ID. So
I think
yeah.
One thing I would add is that this is just something that we've done in a lot of our workshops, because we've noticed that. So the first thing I ever did when I got to Consensys and MetaMask was I created a workshop where all the NFTs had to be stored in like IPFS, and we had to use like what's it called? The pinning app. Anyways, it was a disaster. The workshop was a disaster because the overhead of managing all of those different files and everything was just insane. So the next workshop we did, we said, we're just going to create a dynamic NFT. We know that this might not be the most optimal way to do it. But for teaching a workshop in a shorter period of time, a 1 or 2 hour span, it's always easier to do like an on-chain SVG NFT. I'll stop there, but I just wanted to kind of explain the reason why we chose that on-chain SVG.
Yeah, thank you, Eric. So if you go back to the contract, ballot contract, Kale, so this is where all the management of the ballot happens. So if I'm not going to go line by line and explain all the solidity stuff, but I'll give you the big picture. So for example, we are storing in a special struct called ballot in the line 16, starting from line 16, which is like storing the ballot itself, ID, owner of the ballot, who is the creator of the ballot, their address, and the title, description, and choices. So it's a multiple choice ballot. You can add multiple choices. And then we have another data structure called mapping on line 29, which is called ballots, which is basically a pointer, right? So you have a key and you have a value. So key is the ballot ID and the value is the ballot itself, the structure that I just showed. So basically, it's a way to store the ballot information in the contract that so can retrieve it later time. So if say you need the ballot ID number 1, you can just use this ballots mapping for that one. And if I jump to the create function below, so it's just we are just asking 3 stuff: title, description, and choices. That's all we need for the creating the wallet. And we are just adding the owner property from the message sender object itself, because whoever called this transaction has this property, the sender message the sender, this is the caller's address. So we are attaching that as the owner of the ballot. And then we are creating another mapping called results in the below line 55, I guess. So it is basically a result. It's also a mapping. If you can scroll up, Alejandro, there's a mapping called result. It is a nested line 20. Yeah, that thing. So it is also a mapping, but it's different. It's a nested mapping, which means say that in the wallet number 0, that ID 0, choice number second choice, and how many votes that choice has gotten. So that's why we are tracking tracking in this results mapping. So by wallet, by ballot ID, by choice, how many votes. So that is how we are tracking the results. So that's why we are initializing that result mapping in the beginning. So when creating, those are the 3-4 things we do. We just create a structure and attach to the mapping, and then initialize the new result mapping. And then if you scroll down, it's a get ballots. It's just simply returning all the ballots. And when we are building the front end, the home page, we are just calling this function, which means we get all the ballots that exist in the contract. And you can get the ballot by their ID as well, which is the next function, get ballot. And then the interesting one, mint ballot NFT, the next function. That is where you actually mint a NFT to your address so that you are eligible to vote on any ballot. So
Yeah,
this is
so
just
having an NFT allows you to then select which kind of ballot and vote you want to apply that NFT to. And then
Yes.
I guess once you've voted, can you then use that NFT to vote on others, or would you have to have a new NFT?
You need to have a new NFT. So it's a one time. Like if you use NFT ID, token ID 5 or something to vote on one, you cannot use it to another vote. That's the like token gated part thing. And in the cast ballot thing, it's just updating the results array, but we are checking the stuff you just mentioned, Eric. So in the first line, we are passing the token ID as an argument. In the second argument, we are just checking whether they are the actual owner of this. So ERC 721 has a special function, the owner of, and you get the address from the caller, and you call the owner function in the ballot NFT, and just compare whether they are at the actual owner of the token. And if it is not, we are just reverting the transaction saying that, yeah, you are not the owner of this token, you are not allowed to use this token. And then other basically checks basically whether it has been used previously and the vote has been closed already, because owner can close the ballot anytime they want. Not in the ideal scenarios like in the real world, but for now they can close it. So if it should be open ballot now, and their choice should be a valid choice. So for the choice, they are passing the index of the choice, say 0, 1, 2, whatever the choice, there's an index. And if it is out of bound, we just pass we just revert the transaction. And if it is like valid choice, valid everything, we just update the results. Okay, you have voted to this ballot, to this choice, and update the results mapping in this line, and just then emit the event so that front end can track the like actual transaction in the front end. Get result just that's one. So Ali will show the front end stuff so that you can see that.
I have one last question for the smart contracts and the voting. And the question would be, in our current configuration of the contracts, if someone were to notice that I have a specific NFT in my wallet, would they be able to figure out that a particular vote was from me on a ballot?
Sorry, coming in that token.
So is there any way for someone to kind of figure out who's voted on the ballot, or is that?
Yeah, it is.
So
there's another mapping for that one. So
no. What I'm
Okay.
saying, like outside of the Dapp, like a third party, someone else who also has the ability to vote in our ballot. Is there any way for them to figure out that, like, oh, on this current vote, Eric definitely voted yes on this, or is it impossible for them to figure that out?
I think
you are okay.
Yeah. I think you can know that you voted. We can know that you voted, but we are not going to know for what you
You're not
voted.
going to know what I voted.
Yeah,
Exactly.
Okay.
it is.
So far, that's what I believe also, and I don't believe that there's a way to hack it. But if anyone, that would be a good
Probably
kind
there
of
is.
challenge. If anyone can figure out if we've done anything wrong with our code that would enable that, like, please let us know.
Yeah.
Go ahead.
Yeah. Probably
Yeah.
there's to hack it.
So get results is just if you need the results of the given ballot, you just call this function with the ballot ID. And the get tokens by owner is just you can call it and just get the return. In the return, you can get all the tokens that you have in this contract, plus whether it is being used or not. So if you go back to a call, there's a structure called user tokens in the top, in the same contract in top.
So that's very helpful on the front end, where we want to be able to display all the NFTs that a certain user might own or a certain wallet holder might own. That's what that mechanism is for.
Yeah, the structure is called user token, like token IDs, whether it is being voted on a ballot or not. So basically, it's a utility thing in the front end that we can just show it. Otherwise, they think that they haven't used this token, and they call the contract and fail it. So it's just stopping from them doing that one in the front end. That's pretty much it actually. If you don't have any other questions, we can go to the good stuff, building this stuff.
Oh, great job. I mean, it's a demo application. I mean, of course, there's things that we can do to enhance it, but at the same time, it needs to be able to easily be grokked by anyone who might be in one of our workshops, and it's just for demonstration purposes.
Yeah.
But we try to iterate on these things and make them as kind of solid as possible. So we always encourage people to let us know if there's something they'd like to see in our workshop, or if there might be even any flaws in it, because we are not perfect. Let's go ahead though.
Yeah.
So I guess we're gonna switch over to the front end now.
Yeah. I just wanted to mention that, as you said, Eric, we understand that this could be not the optimist way, but it works for the example. Like the NFT and all that, like on chain. So let's check out to main.
So what we're going to do now is we're going to switch to another branch, which has, I guess, everything a little bit more fully built out.
Exactly. Basically, what we're going to do is this other branch has all the changes made. I mean, in this case, we have the smart contracts, the same that we just reviewed, working and all that. We have already compiled them and deployed them using Foundry, using Forge. I think it'll be a bit longer because the real thing that I am not deploying the real thing because I am not doing this is because I forgot to create my keys on Foundry and I don't want to
No worries.
click them. So, but we already have these contracts deployed.
Yeah.
So we're going to review them. Actually, first,
Question.
yeah.
It's quite random, and normally, you know, like when I'm deploying, I'm always creating an account in Infura or something. Like, what's the plan there with the CLI when you're like deploying something?
Yeah, let's say you'll need an Infura API key in this case because we're using Infura, and that will be on your. If you're using Foundry, you'll need to add that Infura API key to the RPC link that you're going to call to deploy the smart contract. In this case, it's going to be Infura. So you'll have the Infura link with the chain, and at the end, you'll have your API key. So yeah, you'll need an Infura API key and a private key, wallet private key.
Yes.
So
and this when you go for it.
It should be said that if you don't have an Infura API key, if you have an API key with someone else, you would just need to make sure that you swap out that Infura URL and API key with the proper one, be it an Alchemy or a Quick Note or something. But there are certain benefits to using Infura kind of with the various Consensys products, both with the MetaMask SDK and potentially even with Linea. So that's why we're using it. But just know that if you use the CLI, you know, you're not locked into using Infura, but it's definitely an easy option for you, and we make it easy.
Yeah. Actually, if you use, let's say you use Hardhat, let me just do this real quick. Okay, them already exist. Because with Hardhat, the configuration is made in the Hardhat config file. So there, let me just show it to you. You'll have to add basically the M's and just that. Because here we have the Infura RPC link, like the URL, and here we have the Infura API key. So basically what you'll need to do here is just add the Infura API key to your M's and it'll be done. And your account private key, which is your wallet private key. So when you use Hardhat, this is actually easier because you don't need to install Forge, and you won't need to create like the keys for your stuff and all that. So this will actually work pretty well. Okay, so is there another question about that?
I think we're good now.
Okay, so by now, let's just give this a look. This is our front end. This is the exact same app we created with the CLI, but we made some changes to the docs right here. Let's just check the main.tsx, which is what we have installed right here for the WAGMI provider, which is already installed with the CLI. In this case right here, what we did was to create a ballot list component that can display all the ballots that we have created. And let's just give it a look. And we are going to site and dev. So, okay, let's give this a look. Okay, typical, this was working a minute ago.
So while he's doing this, the one thing that I'll just say is that one of the reasons that we built the CLI and we chose not to make a lot of, I guess, decisions for the user. You know, we throw in the MetaMask SDK in there, but we also throw it in working with WAGME, right? So that you could easily change that out for whatever you want. The kind of reason we built the CLI was we go to a lot of hackathons and we have a lot of developers who spend hours putting together their basic project and just wiring everything up. And we thought, well, you know, that's not the work that actually wins the hackathon for you, right? The wiring up of everything. So why not make it a little bit simpler? And so we've already started to have a few hackers use the CLI to start out with, and it saves you a lot of time. And again, we're not making a ton of decisions for you, and we allow you to choose, like, you know, 2 different versions of React, Hard Hat or Foundry, and we feel that most hackers are kind of happy with that. But if anyone has any suggestions on how we can make the CLI a little bit more accommodating for all folks, you know, using Vue or you know, one of these other frameworks.
React Native.
React Native, absolutely. All right, so looks like you got it working.
Yeah. We just had to run npm install and all that. But yeah, this is basically the app that we have right here. As you see, we have 2 buttons at the top, and we have the connect wallet button and the create a new wallet button. Basically, we need to connect our wallet to create a new wallet. So let's do that first, because we don't want to break our application. And after we have connected our wallet, we have it right here. We can create a new wallet or we can vote. But to vote, we need to have an NFT minted. So let's give it a look to how it works. And after this, we can review the code so we can understand first. Let's mint an NFT. Something went wrong. Let's first create a title. Let's create a new ballot we can mint after. We can debug together. I think it'll be fun. Let's say live stream. Let's say hello world. And let's say true. Let's say false. Let's create it. This one should be working. Great, we have this working. By now, it could be interesting to see why we are not able to mint an NFT. Let me just check.
Is it potentially the issue that we had last time with the API key being named the wrong thing? Or no, we've accounted for
No,
that.
I don't think so. We're actually calling the function redirected control function execution argument to data. Let's mint ballot NFT. Let's just give it a look to the mint ballot NFT, which is in the hooks. Use NFT, I guess. Yes. Mint NFT, mint ballot NFT. Here we have the ABIs, the bit. I want to check the EMPs, but I don't want to link it. So let me just take this to my other screen by now. Okay, this looks good.
I just turned off your share screen for a moment while you're doing that.
Okay.
So it's interesting because we were able to submit the ballot.
Yeah.
Which requires the API key. So it seems that that's okay. Live troubleshooting within the demo, as always. The demo gods are always cruel, but you know, we'll figure it out together. That's the whole purpose of these things. So then now we actually get into some live coding.
Yes. Well, basically, this will help to understand like the functions we are calling. You can share my screen, Eric. I won't link any private keys. But yeah, basically here we have the mint NFT function. We are using write contract in this case, which is a hook that comes from WAGMI, which uses VM. So yeah, basically with this use write contract here, we can get the write contract function, and we are calling it right here. Basically, this function receives the address of the contract we want to call, the ABI of the contract we want to call, and the function name. These should receive some parameters, right? Like arguments. Basically, that could be the, let me just check the main function if we need any parameters. So, save min, yeah, we need the minter. So, I would say that this should fix.
So you're just passing your address along,
Yeah.
right?
But the arguments right here, undefined is not a thing. Okay, let's just check if this works this way. Seems like it's not. Let me just reload this. Okay, yeah, we're not receiving any arguments. But here in the safe min, we have the address of the minter. But we're not calling safe min, we're calling probably this one. Mint ballot NFT. Yeah. Probably. Do you have any idea, Chin?
Yeah, looks like I'm having the same thing. I'm just debugging in the background. So maybe
Cool.
if you can share any other stuff.
Yeah. Also, probably Eric. Oh, I have Eric's. Yeah, this is the contract from Eric. So yeah, let's give it a look to other part.
I'm going to
of the
pull
code
up my
to
working
figure it out.
version real quick just to see if I have
Okay.
any different luck, but go ahead for a moment while I do that.
Okay. Great. So yeah, basically this is normal in live coding sessions. So everything breaks when you're live, but yeah. So yeah, we have these hooks right here where we are able to get the NFTs, actually read the contracts NFT, so that way we can have the tokens by owner. That way we can know if you own or not an NFT, and you're able to vote if you can mint an NFT, which you can't right now, but we are going to fix it. And yeah, basically we wait for the transaction to be confirmed, and we return these values right here. We also have the use ballots, that TS hooks, where we are able to interact with the ballots actually. And the same, we're using WAGMI hooks to interact with the smart contracts. Here we have the one that created the ballots. That one works. We just created one. And basically we're returning also the ballots, the ones we already have created, and the states of the transaction, if it's confirmed, if there was an error or confirmed, and so on. So when we come to the components right here, we have several component. This one will truncate the address for you to see it, like with the ellipses and all that. We have the connect ballot button right here. We have the create ballot form. We're using SAT, if I'm not wrong. Yeah, for the data schema and all that. These are technical stuff, but React stuff or TypeScript stuff. So yeah, basically this is what we have. Would be great if we can fix the
Is it
bug
possibly
line.
a formatting error? Haven't we had this issue before where we had like a formatting error? I'm not sure if it was the big num or the number. issue with
We had-
the.
Yeah, we had another, which was the one that we were sending begins instead of numbers. And yeah, but in this case, it doesn't seem to be that one, because let me just check. Format error.
It's always something small.
Yeah.
Looks like the function name is correct.
Yeah, the function name is correct.
The ballot ABI wouldn't be a problem. It's showing up. It's not having no problem finding the ballot. Could it be this address? So Veet ballot contract.
We're actually, that's the ballot contract, and I think we have it because we're getting the ballots actually. And here in the ballot, like the ballot contract, we have this mint function right here, mint ballot NFT, which is basically this is the function that's not working. For some reason, let me just try something. Let's see this. This won't compile, but I already compiled. Yeah, the smart contracts here looks good, actually. So RPC request.
Alejandro, I doubt that is the contract itself, the deployed contract. Do you have the contracts that deployed in the production version? Because it is working, like live version is working.
Okay, probably. Yeah, I thought about that. Can you send me the address so I can add it?
So swapping out the two different contract addresses, maybe that might be working on an
Yeah.
older version of the contract. Since we
Could
didn't,
be, yeah. I mean,
yeah, because
this
we didn't
one,
deploy these contracts. We used the ones that I had deployed, right? Which could be an
Exactly.
issue. Okay.
Exactly.
Yeah, because I checked the hook and the contract. It looked like everything. There we go. So it's in our private chat.
Okay. Cool. Wait a second. I will. If you can hide my screen.
Yep.
Great.
So this is just goes to show that if you're working on a project, right, where we might have gone wrong here is that to try to save time, rather than deploying the contracts and potentially exposing some keys, we decided to go with two contracts that have already been deployed. Now, what if those contracts had been updated since then, and I'm working on an older version? So that's potentially one of the issues. Also, I mean, it's most likely that's the issue rather than any of our front end code, that we're working on a slightly different version of the contract. It is weird, though, that the ballot's still submitted, but not the NFT. So
Yeah.
maybe the issue could be that the NFT contract had been updated just by itself.
Yes. Wait a second. in this case,
So considering that we've got a ballot,
yeah.
if we swap out the NFT contract and it works, then hopefully we'll still be able to work on the same set of ballots, but we'll be using an updated NFT contract. Ballot NFT contract versus the ballot contract, which is probably fine.
Wait a second. If you have the link of the production version, just to showcase how it works, because in this case, I'm not sure.
Shintaka, do you have the link to the production version?
It's in the chat, Ali.
It's in the chat?
Cool.
Yeah.
All right, so let's switch over to that just for sake of time, and we'll check that out.
Yeah.
This is exactly what we want, like, live codes, debugging, live.
Yeah. It is actually cool. Yeah, you
So
can share my screen now.
the other option would have been to actually have Alejandro redeploy the contracts with his current setup. Okay.
Wait
So
a
let's go ahead
second.
and create a ballot.
Yeah, this one. Wait a second. Wait a second. Okay. This one right here, you can give it a look, right? This one is reveal results because we already have created this ballot. I can create a new one. This is the production one. I don't want to mess it with test values, but we can deploy another contract, right? Chin, do you think it's okay?
We can add a ballot here.
Yeah,
Okay.
we can decide.
Let's say this is the best ballot. We are going to have this the best.
We should have created a vote on whether we thought it would work or not.
Yeah,
Have everyone vote on it.
not the best ballot. The best
I
ballot.
think it's going to be the best ballot.
Me
And then
too.
share the link.
Yeah, we can share the link.
So we get the
Okay.
MetaMask pop up on the ballot, which is good. That'll create the ballot.
Yeah.
And then we'll need to mint
Okay.
an NFT so that we can vote on our ballot.
Okay.
Now NFTs.
Okay, I have this one NFT, but I already used it.
Oh, you
So
already
we
used
have
it.
this stack right here.
So you're going to have to
and
spend
it
some
can
gas
have
on a
this.
new one. Hopefully
Yeah,
I gave
if
you
I
enough.
try to vote, it'll say that I cannot vote because I have already used the NFT.
Yep.
So I need to mint a new one. Here we have it. Cool, working. It's crazy.
Yeah.
It works on the deployed version. Probably it's a smart contract stuff or
It's
local.
the
One
contract,
thing
yes.
we'll do
Because it's
is-
the same code. Yeah?
Yeah, after the live stream, we'll check why maybe that wasn't working. What we'll probably do is pull down the existing code just to make sure that it works. That way, in case anyone goes to that repo and pulls it down, that they're not going to have any issues. It probably won't be an issue. The most likely reason is that we were working with an old NFT contract. That's probably the reason. So cool. So you got a new NFT now, and this should allow you to
Yes.
vote on any ballot, but we only have one. And you can
Exactly.
select which one you want
I
to vote
can-
with.
Exactly. This is selected. We have it right
These
here.
are all non-used NFTs.
Exactly.
Perfect.
And we have the two options right here. For my case, this is the best bubble for sure. And I can vote. So yeah, the transaction, we can confirm the transaction. And now I can see the results. You'll be able to see the results only if you have voted. So
Right now, if we had 10 people go to the production version and everyone minted an NFT and voted, within a few minutes you would be able to see those results. So
yeah. If you wanna do it, would be great.
If you have
Want to
Linea
vote.
Sequoia token,
Yeah, exactly.
yeah, so
We
you would
can-
need to have Linea test ETH in order to do it, which maybe not everyone will have. I don't think it's a problem to share the live version. If people want to try it out, we can do that. You know, we can always redeploy a new one if something gets screwed up. Looks like, do we have a second vote here?
No, it's
Here, yeah, here we have 3 votes. Here we have 3 votes.
Chintaka, talk to us a little bit about this this kind of view right here, because this is something that we added a little bit later on, right? We got all the mechanics worked out first, and then I believe was it you or Alejandro that added this kind of screen right here with the graph that shows the results of the ballots? And were there any challenges to this, etc.?
Yeah, the major challenge is like mostly working with Web3 stuff is that say that you execute a transaction, mint an NFT, vote, cast a vote. Thing is, you don't get the response back quickly. So what happens is you just put it into the blockchain and you get a hash, transaction hash, and it will take time to actually commit it to the blockchain, and you don't get the results. So that's why we are trying to use WAGMI for this, WAGMI hooks, which is working perfectly with React and other Next.js stuff. So we have a WAGMI hook. Name is that I can write a contract, which is basically mutation in the blockchain, like basically writing, like casting ballot, etc., and minting a NFT. Reading is always free, that as you know, and it is faster as well. Reading of the ballot, it is free and fast, but writing is expensive because you have to pay the gas and you have to wait until it is being committed to the blockchain. So in the WAGMI, it's make it easier to do that one. So once you write a contract, you can wait for the transaction to be completed, wait for transaction to be completed, and pass the hash to it. And
which, by the way, is something that every Web3 developer should kind of be aware of with WAGMI, is those kind of wait for transaction
maybe
hooks that they have.
you can show the code itself. It is clear, like show something like use NFT or use voting hooks. This thing, yes. This is use NFT. So this is like the custom hook we will be built. Use NFTs. There is no use NFT hook in WAGMI. So we are using under the hood WAGMI, but we have built the custom hooks that React folks know that custom hooks about custom. So basically, as you can see, use React contract. That way we get the NFT contract, and in the mint NFT, you call the right contract from WAGMI itself, and then it will give you a hash, transaction hash, and then you can wait for the transaction to be like completed.
So
and that is
are we using use contract write and then using the hook use wait for transaction, or are we using use send transaction?
Use write contract.
Exactly.
Use write contract.
In this case, with WAGMI, we don't have to wait for the transaction to be completed. I mean, we're going to have this right here is pending data hash. If the hash exists, is that the transaction has succeeded. If not,
we're using use wait for transaction receipt. My bad.
Receipt. Yeah. And in line 17, we are waiting for the transaction receipt.
Yeah.
That way that it is actually completed, and it is confirmed in the blockchain.
Exactly.
Got it.
Then we update the front end saying, okay, this went through and you have an NFT and your ballot is created. So that's the thing. And then one cool thing about query client. So under the hood, WAGMI uses React query, Transact React query. So what we do is, as you can see in the front end, as soon as you mint an NFT, the UI is updated straight away. It's like you will see the NFT that you have just minted. That cool part is happening inside the use effect. If you can see line 41, if the transaction is confirmed, we are just revalidating the query, which means we asking like, if it is successful, it is confirmed, we are asking to fetch fresh data from the contract, like fetch all the data that we need. In this case, it's just your NFTs. Your NFTs owned by you.
So the use wait for transaction receipt is basically just a WAGMI hook that it waits for the transaction to be included into the block before executing any other code, which I believe that when we had our old NFT tickets demo, same kind of thing, right? when someone minted a ticket, we wanted to wait for the transaction receipt before trying to display those NFTs on the screen for the user. Kind of in the same fashion that we do here, where we show what NFTs are owned by a particular user.
Yeah.
Makes sense. Awesome. All right, so we are at 11:15. We are pretty much at time. So we wanted to try to keep this to an hour, but it's okay if we go over a few minutes. I just want to know, Alejandro, Chintaka, is there anything else that we should show off here? I mean, other than just saying, hey, try out our CLI and, use it for a new project. Let us know if you have any considerations or things that you'd like us to update, if you'd like to help contribute to it. But is there anything else you think that is really important that we show here?
Yeah, not sure exactly, but I would say that rather than deploying the contract to testnet straight away, just try it locally with hard hat node, like having local setup that test it properly, because deploying to testnet costs gas. So you can try it locally, see if it is working, test the contract properly, and then push it to testnet and do the stuff there. So that is one thing I would suggest, like if you are starting from the beginning.
Yeah, and I would say that, of course, not all of the users, but if anyone in the chat wants to try it and needs some líneas Epolia, just they can just reach out. I will give them some so they can start interacting with the blockchain. That could be also cool. So you can start building with Linea, and yeah, basically that.
And so the link that we have up on the screen right now, that's the Web3 full stack starter. That's the source code for the project that we've been previewing here. And the README that you have up right now, if you were to go to that link, is the proper README, and that README will walk you through how to kind of deploy the contracts and get everything set up and configured so that you can run this locally. Of course, like he said, you can deploy those contracts locally or to the testnet. I think the README shows how to do it on the testnet, but you can do it either way. And yeah, so that's the code for that. And then we also have the code for the CLI, which I'm going to also put up here really quickly. So I'm just going to, let's see here, do it on MetaMask Developer. So I'm going to show that one real quick. So this is the Create Web3 template, which you can just search for Consensys Create Web3 template in Google and find the CLI. But this would be the code, the repo for the CLI, which just the README there just shows you how to use that CLI, which is what we did at the beginning of the video. Awesome. If there's nothing else, I want to say big thank you to Alejandro and Chintaka and Francesco for joining us, asking good questions, kind of showing off how we built this. And then I would just ask that if anybody's watching, that, if you see us coming up on Twitter or YouTube with some live streams, check in on us. We'll be doing more of these kind of on a regular basis. Hopefully we can do one a month, if not maybe more, and have like really good developer content on how to not only use Consensys products, but also how to use other things out in the ecosystem. We're not specific to showing how to build things in and around Consensys products only. We'll definitely try to showcase as many cool things that I think Web3 developers, it would be helpful for them to use. So yeah, any closing thoughts, guys?
I think that's great. Let us know which examples and kind of vertical you want us to build a tutorial with the CLI, and we can definitely try it out for the next time.
Absolutely.
Thanks, guys. Amazing job.
Thanks, everyone, and everyone watching. Have a great day. Yeah, see you later.
Thank you.
See you.